How are we on this absolutely fantastic day? Let's do this. Let's talk about subtraction. But before we talk about subtraction, let's talk about where we used to be. Let's talk about addition and the difference between addition and subtraction. So here's an old addition problem, okay? Here's what I've said about whether you're doing an addition or whether you're doing a subtraction. Every single time you get to a column of numbers, one on top of the other, right? Whether it's the ones or the tens or the hundreds, whenever you do this, you always have to ask yourself a simple question, okay? Now with addition, the question that you used to ask yourself when we were doing that was, will my answer for this column of numbers give me a 1-digit or a 2-digit answer? 1-digit or 2-digit? Okay. Now, if it gave you a 1-digit answer like this, okay, let me, what am I doing? How have I not expanded it? There we go. If it gives you a 1-digit answer like 0 plus 9 equals, then you're fine. You don't have to do anything, right? But if you have a situation like this, 9 plus 9, you get an 18, and then you have to regroup, what we used to call regroup or bundle, or something like that. So where the 8, we have to split up the 18, right? The 8 goes down there, the 1 goes up there. But Mr. Brown, this is supposed to be a subtraction video. I know. But the basic idea is this. Even if we're just doing subtraction problems, we still have to ask ourselves a simple basic question every single time. Let me see if I can sharpen this. That's a little better. We still have to ask ourselves a basic question every single time, okay? And for subtraction, it's a yes or a no question, a yes or a no. And that question is this: can we subtract these two numbers in 4th grade math? I say in 4th grade math because we don't do negative numbers in 4th grade math, okay? We don't do that. We don't do 4th grade, all right? We don't do that. So basically, if the top digit is smaller than the bottom digit, right? It's a no. We cannot do that. We cannot do that, okay? If the top digit is larger than, for example, so this is let me see if I can find one in my stack that has, okay, here's one, okay? Here's a subtraction problem. This is a yes. 6 minus 2 is a yes. That's a no. That's a no. So ask yourself that question every single time. Can we subtract these two numbers in 4th grade math? And it'll be a yes or a no. And if it's a no, we will have to do something special. So you should have a notebook in front of you open, or a lined piece of paper or something. Everything that I do, you will be doing. Okay, so everything I write down, you write down. So let's start with our first subtraction problem. 2,431 minus 1,470. Now, as I say every single time, 1,000 million times I said this, pause the video as many times as you need to so that you can write down this neatly. I go fast so that you can go slow. Also, it's extremely important that you line up the digits properly. I call it lining up like toy soldiers. Okay, where the ones are on top of the ones, exactly. The tens are on top of the tens. The hundreds are on top of the hundreds, exactly. Okay, so let me get my blocker out here, right? I'm gonna get my blocker, which is just to basically, you're not gonna have a blocker, but this is what I'm gonna have. So we can just take this 1 digit at a time, right? We always ask ourselves the question of this. Is this a yes or a no? Can we do 1 minus 0? Yeah, the answer is yes. We absolutely can. Okay, so let's do this. 1 and take away 0 is just 1. Okay, then we move on to the next one. Okay, 3 minus 7, yes or no? Can we subtract that in 4th grade math? No, we cannot. The top number is smaller or less than the bottom number, so we cannot subtract that in 4th grade math. So what do we need to do? Now, I've been saying this over and over and over again, and I'll say it again. It's really important to me that you understand the reason why we do this crazy rule, where you take 1 away from one number and you add 10 to the number next to it. Well, that's obviously not the case. It's obviously not 10. You're adding 10. Hello, Mr. Brown, have more coffee. So that becomes a 13. Okay, now the reason why is because when we unbundle this, 100 is equal to 10 tens. It's the same thing. 100 and 10 tens is the same thing. So that's why we take 1 away from this number and we add 10 to this number. It's really doing the same thing. You're just unpacking it. You're unbundling it. Okay? It's really important that you understand why. And it doesn't matter where in how far down over to the left we do this idea. You always take 1 away. 1 of this is equal to 10 of this. 1 of this is equal to 10 of this. 1 of this is equal to 10 of this. When I say this, I mean the place values. Okay? So, I know it's a weird concept, but it's really important that you understand that that's why we do this. Now we have enough to take away. 13 minus 7 is 6. Now we've created another, right? This used to be a yes. 4 minus 4 used to be a yes, but now it's a no. And that happens sometimes. Sometimes that happens where we start off with a yes, but it becomes a no after the process of regrouping or unbundling. That happens sometimes. So what do? We go over here. Okay? And again, 1,000 is equal to 10 hundreds. That's why you take 1 from here, doodle-doodle-loop, and you add 10 to the third. Now, we're not adding 10 to the 4. That's not a 4 anymore, right? That 4 turned into a 3. So we're adding 10 to the 3. Remember, it's no longer a 4. Take away 1, add 10. Now we have enough to subtract, okay? 13 minus 4 is 9. Now, for this last piece of the puzzle, could you put a 0 there? Sure. You wouldn't technically be wrong. You don't need to. 1 minus 1 is 0. You could put a 0 there. I usually don't. I usually just leave it blank, but you can certainly put the 0 there, and that's fine. If all of this was a little confusing to you, I give you permission to turn back that video a couple of minutes and watch me explain this whole thing again. Because this is why we're here, my friends, okay? So this is why it's on YouTube, so that you can go back and say, I need to hear that again. I need to hear that explanation again. I don't understand why the 3 became a 13. I don't understand why the 2 became a 1. If you have those questions, go back in time. Go back in time. Now, for our next one, skip a couple of lines. In honor of Halloween, we're going to do a Halloween example. 422,431. I mean, you might be watching this at a different time of the year, depending upon who or when you are. But when I'm doing this right now, it's around Halloween. Minus 92,420. Now, why I say this is a Halloween example is because this looks scary, but it's actually not. It's a look scary, not scary. This is what I call this. Look scary, not scary. Because really, if you take a look at this and you look at things one at a time, you actually don't really have to do an insane amount of regrouping here. You know, maybe you could look at, pause the video and see how many times do you think you're going to have to regroup it. Go ahead, do it. Welcome back. You're only going to have to regroup, I think, once. That's why it's a scary, not scary. Okay, that's why it's a scary, not scary. If you really looked at all of it and you ask yourself, yes or no, only once in this big fat example. So let's just go through this. 1 minus 0 is 1. Oh my gosh, this is easy. 3 minus 2 is 1. 4 minus 4 is 0. 2, I told you it was scary, not so scary. I told you. I don't mean to say I told you so, but I told you so. Okay, so we're finally getting to this point right here. Okay, 2 minus 9 is a no-no in 4th grade math. We do not do negative numbers. We're not going there. Okay, so again, 1 of these is equal to 10 of these. You know what I mean? But here's the deal. 100,000 is equal to 10 10,000s. So that's why we do what we do. That's why the rule is what it is. And the 2 turns into a 12, because you're taking away 1, adding 10. Take away 1, adding 10. Just like we did up here. Take away 1, adding 10. Take away, you get the idea. 12 minus 9 is 3, and just drop the 3, right? It's the same as 3 minus 0, just drop it. Okay? Now, that was our Halloween example. The next is our dominoes example. It's a domino. Have you ever seen people like set up dominoes and then set them up, goes tick, 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 right? And all the dominoes go. This is called a dominoes example because, well, you'll see why. It looks pretty simple up front. Looks pretty basic. 2,460 minus 1,472. Looks pretty unremarkable. Pause the video so that you can copy this as perfectly as I do. See, look at the toy soldiers. Look at the toy soldiers. So, yes or no? 0 minus 2. Now, if you have an empty plate, you can't take 2 brownies off of it. Come on, folks. You can't do that. So some folks don't like this because, well, how am I supposed to take from this? This is a no too. This is also a no. So how am I supposed to take from this if it's also a no? 6 minus 7, you can't. Well, you can still take from it. Listen, it used to be a no. It's still going to be a no. It used to be a no. 6 minus 7, it's still a no. Nothing's really changed. Nothing's really changed. 1, 10 equals 10 ones. That's why we do what we do. Take away 1, add 10. Okay? Now we can subtract. 10 minus 2 is 8. Uh-oh. Oh, boy. Yeah, this one's a little messy. Where are the dominoes? Tick, 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 tick. This problem leads to this problem leads to this problem. Now we're going to create a whole new problem. This used to be a yes. Hooray! Now it's a no. Boo. Dominoes, man. Dominoes. Right? We're creating these situations where it's just a domino effect. Every time that you take away, you now create a new problem that you have to solve later. Well, that's life. Take away 1, add 10. Notice how we are adding 10 to the 5, not the 6. It's not a 6 anymore. It ceased to be a 6. It became a 5. Right? And then that 5 became a 15. Take away 1, add 10. 15 minus 7 is 8. 3 minus 4, nope. Let's go next door. Take away 1, add 10. Take away 1, add 10. 1,000 is the same as 10 hundreds. That's why we do it. Now we have enough. Oh my goodness, dominoes. Tick, 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 tick. 13 minus 4 is 9. 1 minus 1, we'll just leave it blank. Yeah, so that's a complicated example. But if you just take it one step at a time, that's always been my advice all along, folks, with whatever we're doing. Just take life one step at a time. That's a life thing. Just take life one step at a time, and you'll be fine. And this seems very overwhelming when you look at it all like this. That's not so bad. That's not so bad. You get the idea. Last but certainly not least, and here's where things get a little bit funky. We're going to subtract across zeros. And this is going to be a real doozy, folks. This is going to be a real doozy. Wow. Really, Mr. Brown? Yep. This is a doozy. Check this out. Pause it so you can do it as neatly as you possibly can. Subtracting across zeros is a real weird thing because obviously we know when we start that we can't do that. But we also cannot go next door to this house to borrow anything. And we also cannot go next door. These folks have nothing for us to take. So we've got to go 1, 2, 3 houses over to borrow some sugar. 1, 2, 3. So if we need something here that we could subtract because 0 minus 9, nah, you can't do that. You got to go all the way over here and take 1 from that. Now, here's the thing. You cannot magically fly over all these other little houses and make this a 10 right away. Not yet. Not yet. All right? You've got to go to each house, and you've got to go boom, boom, boom. You've got to bounce back. So this is where things get a little bit weird, okay? So This is how it works for subtraction across zeros, okay? Take away 1, add 10. Well, that doesn't do me any good all the way over here. Take away 1, add 10. Well, that doesn't, wait a minute, that doesn't do me good. That doesn't do me any good all the way over here. Take away 1, add 10. So really it becomes, all the middle zeros become 9s, and this little anchor position at the end, that's where the 10 finally ends up. It's a reverse domino effect. It's really kind of a strange one, but subtracting across zeros, that's how it works. Okay, you can't just take from here and go wee and fly all the way over to there. It has to go to each house. It has to go to each house. 10, take away 1. 10, take away 1. You know what I'm saying? It's got to go like that. And once you have this, then you can finish the subtraction, right? 1, 1, 0, 7, 5. Yeah, I'm going fast, so what? Okay, so you might get the idea, you might not. I want you to think about each one of these examples. The subtraction across zeros, the domino, the scary, not so scary, and whatever we call this one. And I want you to put a little star or an emoji next to each one about how you are feeling about it. I think an emoji would be great. An emoji here, an emoji there, about how you're feeling about it. So we can have this conversation when you're done with this video about something you want me to talk more about. Okay, so put emoji, 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 and then we are good to go. Folks, have an absolutely fantastic day. I will see you soon.